Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we'll discuss question number 26, NEET Physics paper 2016. Student, let us solve question number 26. The intensity at the maximum in Young's double slit experiment is I naught. In a Young's double slit experiment, this is Young's double slit experiment, this is source S1, this is source S2. This is the screen where the interference pattern is formed. Now, it says that the intensity maximum is I naught. So, suppose these are the positions where we get alternate maxima. The maximum intensity formed obviously at the central bright fringe. This is central bright fringe because at the center we get a bright fringe, and that is having intensity I naught, which is, if I consider this as this consider this as I1 and this also as I1, I know that individual intensity is, suppose I1, then I naught is obviously equal to 4 times I1. That is very clear. So this I naught is basically equal to 4 times the individual intensity. Next is distance between two slits is D. So this distance of separation between the two sources is that this distance is D. Distance between two slits. And that D equals to 5 lambda. So what is given is D equals to 5 times lambda. Where lambda is the wavelength of light used in the experiment. What will be the intensity in the front of one of the slits? So in the front of one of the slits, suppose this is the point I consider, and this point, you have to find the intensity. What is the intensity at this point? At a distance D equals to, a screen placed at a distance D equals to 10D. So this D equals to 10 times this D. Okay, that means this D is much greater than the distance of separation between the slits. So with this informations, we can I'll just help you find this. So in this information, we're going to find the intensity. To get the intensity at a point, we must have to apply the formula that intensity at any point P equals to I1 square, that is amplitude square, this is I1 root, plus I2, that is I1 again, plus 2 under root of I1 I2, that is I1 again, and cos of phi. Okay, because intensity is proportional to square amplitudes, so it is like that. Initially, both the sources is having intensity I1, so I'll put I1 and like that. This is 2I1 plus 2 under root of this is I1 cos phi. From here 2I1 common, it is 1 plus cos of phi, which is 2I1. 1 plus cos theta is 2 cos square theta by 2, 2 cos square phi divided by 2, 2 to the 4, so 4I1 cos square phi by 2. This 4I1, as I told you, is nothing but I naught. So therefore, this will be I naught cos square phi by 2. This is the intensity at any point. For this situation, for this question, I am getting that IP equals to I naught cos square phi divided by 2. Now, to get this, I have to find phi, the phase difference corresponding to the point in the screen in front of this source. What phase difference or what path difference these two rays will create at this point P. The path difference between the two rays traveling to reach up to this point, the path difference equals to path difference can be obtained as S2P minus S1P. This is the path difference at this point. This S2P, this distance is D and this distance is 10D because that is our capital D. So S2P is D square plus D square under root minus S1P is your D. So from here, if I take D common out, this will become under root of 1 plus D square over D square minus D. This is D common. I will write this as 1 plus D square over D square under root minus 1. Okay, now from here what I'll get, this path difference equals to capital D. Now we have one binomial expression, binomial theorem for smaller index, which says that 1 plus x to the power n equals to 1 plus nx. This is true only when x is much less than 1. So here 1 plus d square by d square over d square to the power half, and minus 1 is there, minus 1. This one, I consider this as x and this half as n. Then because this is very small, because this is much greater than d, so I can write this expression as d 1 plus nx. This I have to multiply with this only, so it is d square over 2d square minus 1. This 1 is there. This will cancel out. This is d into d square over 2d square. 1d will cancel out. So this is equal to d square over 2d. So the path difference I am getting, path difference, this is the path difference to reach the point P on the screen from both the rays equals to d square over 2d. But we have already known that d equals to 10 times d. So if I put that, the 1d will cancel out, so it is d by 20. So this is the path difference I'm getting. Okay, now again in the question I have d is equal to 5 times lambda. So this is given that you can see here the question is given the distance between the two slits is d, which is 5 times lambda. So in place of d we can use 5 lambda. If I use 5 lambda, this is 5 lambda divided by 20, which is 5 fours are, so it is lambda by 4. So what I am getting is that path difference is lambda by 4. So when you have path difference lambda by 4, the phase difference phi, or only I say phi, equals to 2 pi by 4, because path difference of lambda corresponds to phase difference of 2 pi. So 2 pi by 4, which is pi by 2. So if I get phi equals to pi by 2, that has to be substituted in, that has to be placed in the original equation that I got to find the expression, that is this one. So if I put that, ip equals to I naught cos square phi by 2, that is pi by 4, which is equal to I naught cos square, this is 1 by root 2 square is 1 by 2. So ip, I am getting I naught by 2. If I see that, then this is the right answer to this question. So that is the answer. Okay, thank you.